Class, we're going to go over 10.3 today, or 3.3, depending on the book, but we're doing 10.3 right now. Anyway, this is for business calc, and today we're going to cover what to do if you have two functions that you're multiplying or dividing. So far, our rules, like you have to be able to simplify it and make it be written a specific way to be able to take the derivative. So we have what we call the product and the quotient rule. So that's what we're going to go over today. Let me go ahead and share my screen. All right. Okay. Oops, this thing's kind of sideways. So theorem one is our product rule. So if we have two functions that we're going to multiply together, then what do? Well, let's think of our first function as f, first, s, second, first, second, get it? So if we have our functions f times s, then the derivatives have to exist for this to go on. In regular calc 1, you might have a lot more where it doesn't exist than we will in business calc. So what is the rule? The rule is then you can find the derivative if you do the first, original first, see, no prime on there, times the derivative of the second plus the second original times the derivative of the first. And it works out. So if you're multiplying two functions, you can do original times the derivative of the second times the derivative of the first. All right, so we get a little lazy. Here's some other ways to write it. My favorite is this one. So y prime, I don't even want to write f of x. I can do first times derivative of the second plus second times the derivative of the first. By far, the best way to write it to me. This is another way to write the notation, but again, it's a little tricky. And yeah. Okay. So if I have something, well, let me go ahead and just write it on my own paper. I like to write it out myself instead of just show you the steps. So problem number one, if I have a function like 2x squared times 3x to the fourth minus 2. There we go. I am going to do the product rule with this, but you should already be thinking, well, I can just multiply it through and use my exponent rules. You could for this one. I want us to do an easier one like this to start out, but honestly, multiply it through, then you don't have to do the product rule. Totally okay. But let's look at what is our function that is first. Well, that's going to be this one times this one. So it's going to be 2x squared. Okay, then let's look at what is the second function. Well, it's going to be the one in parentheses. So that's going to be 3x to the fourth minus 2. So first, second. Now let's do the derivative of both. So what is the derivative of the first function? Oops. Then it's just 2 times 2 is 4. X to the first, or x. Okay, derivative of the second here is going to be 4 times 3 is 12x to the third, and the minus 2 disappears. So now you have the originals, you have the derivatives, so now we can follow our rule and say that the derivative of this function is going to be, what did we say? We said it was, maybe I'll write it up here. The derivative of it is going to be first derivative second plus second derivative of the first. There we go. We have it close. So we want the first, which is the 2x squared. And the derivative of the second, I'm using parentheses, is going to be 12x to the third plus the second, which is 3x to the fourth minus 2. And then the derivative of the first is 4x. I always use parentheses just to help me remember that it's really times in here and times in here. Okay, so then this is just simplifying. So let's multiply these two. And 2 times 12 is sometimes 24. X to the third times x squared. Add those exponents, and I'd get x to the fifth. So 24 x to the 5th here. And then over here we have our plus. And then I kind of like to think of the 4x being multiplied this way, just because that's the two terms, that's the one. So 4x times 3x to the 4th would give me 12x to the 5th. 4x times 2 is a negative 8x. All right, these have the same term, so what's 12 and 24 when we add them? That's going to be 36 x to the 5th minus 8x. Done. There's our derivative. All right, so first, second, there we go. That's how we do it, and we have two things being multiplied. Again, could have multiplied this from the beginning, done the derivative, been there a little quicker. Totally would have been fine, but I wanted to make sure we did the first and second. Now let me have a first and second quotient. Oh, I thought yep, I don't have a super quick one there. Do I have one on my first, second? No, this is my quotient rule. Never mind. It was under, I was like, I had a second problem. So what if I have something that can't be multiplied quite as easy? What if I have original function is going to be 7e to the x times 7 natural log of x. So here's a function where I can't multiply it out. I truly have two separate product functions, and I'm going to have to use my derivative rules because I can't do something that's times. Plus in between, I could have, but not times. I have to use my product rule. So again, we're going to do our first. So what's our first here? It's going to be 7e to the x. What is the derivative of 7e to the x? 7e to the x. We like e to the x's. Okay, so then the second function is 7 natural log of x. Now that could have also been natural log x to the 7th power. You would have then had to remember to bring the 7 down out front, then go from there. So just a reminder of that rule. Okay, then from here, if I'm going to do the derivative of this one, it's going to be 1 over x with the 7 on top. So it ends up being 7 over x, right? Because the natural log of x part is 1 over x, but the 7 just stays up front. There we are. So now I can go, okay, the derivative of this is going to equal first 7e to the x times the derivative of the second, which is 7 over x, plus our second 7 natural log of x times the derivative, which is 7e to the x. Now simplifying that, not a whole lot we could do to simplify. My math lab is great. It really will take this as your answer. But I want you to think of this as being on the denominator. So it's like this is over 1. I could times this by this, and I end up with 49 e to the x on the top over x. Plus, I can times these and get 49 e to the x natural log of x. So there you go. All right. So there's one where I kind of feel like I have to use that product rule. You can pause that if I went too fast. Okay, next rule. What if these things are being divided? Okay, so this is going to be called the quotient rule. Okay, so quotient rule. What if something's being divided? So you have top and bottom. Look, first, second, top, bottom, works. Then, and we know the derivative exists, then the rule says that you do the bottom times the derivative of the top minus the top times the derivative of the bottom, similar to the product rule, but now I have a minus, so I have to go in the right order. Now, the product rule is forgiving because it's a plus. Be careful. And the bottom squared is in the denominator. That's our rule for quotients. Okay, shortcut, bottom derivative of the top minus top derivative of the bottom over b squared. So they have a saying that goes low d high minus high d low over low squared. There you go. So you'll hear that from people. Oh, quotient rule. I'm going to need low d high minus high d low. Either way. Okay, let's use it. What's my first kind of easier one? All right, this is my first one in the quotient era here. So what if I have x squared over 2x minus 1? Okay, x squared over 2x minus 1. What is our top? Our top is x squared. What is our bottom? Our bottom is 2x minus 1. Now let's do the derivative of each of those. What is the derivative of the top? The derivative of the top would be 2x. What is the derivative of the bottom? Just 2. So those are pretty easy ones. Oh, and what does it say? Low, d high, right? So we got to start with the bottom original. So for the derivative, we have bottom original 2x minus 1 times the, so it goes low d high, so derivative of the top. So the derivative of the top is 2x. Minus x squared, the top, times the derivative of the bottom, which was just 2, all over the bottom squared. Ta-da. Now we can simplify this out, distribute this one, and I'm going to end up with, I'm just going to do a shortcut and show you the answer here. We're going to end up with 4, oh, nope. We're going to end up, if you want to pause and simplify that, I was like writing down the halfway there, 2x squared plus 2x over 2x minus 1 squared. Now, my math lab will typically take it ugly here, but I really want you to know you can simplify, and that's important. Sometimes you're going to have to. It just depends. Okay. Let's see. That one's pretty similar to what we just did. And that one's too easy. Do you like that? Too easy. Oh, this one's hideous. Let's do it. Foil. Ooh, and that one. Okay. So let's do, like that I said, it's hideous. Oh, let's do it. It's not really that bad, but. All right, so what if I have 8 times the 4th root of x, and this is going to bring in the rules with our radical, which is why I like it, over x squared plus 4. All right, so what's your top? Okay, well, or bottom, whatever one. The bottom, I guess I could call it bottom of x, whatever. I could have just said b equals, it doesn't really matter. So the bottom is x squared plus 4. What is the derivative of that one? It's going to be 2 times x, and the 4 drops off. So what is the top? The top is 8 4th root of x. What's another way to write that so that I can have exponents and use my exponent rules? Will be 8x to the 1/4 power. 1/4. Okay, I need that. So what's the derivative of that function there? Well, I'm going to have to take the 1/4, right? The 1/4 times 8, which is going to give me 2. I'll write that though for you. So we'll have 8 times the 1/4, and then you're going to have x to the power of 1/4 minus 1. What will that simplify to? 8 divided by 4 is 2. 1/4 minus 1 is going to give you x to the -3/4. If you can't think that through, which is fine, I know you should buy business calc, but if you can't, get a common denominator, use a calculator, one of the two. All right, so then from here, we would have our derivative, and our derivative says, what do we go first? Low, bottom, d high minus high d low. Okay, so we're going to have our low first. So our bottom was x squared. I thought I wrote it down on my paper wrong, but I did not. Okay, times the derivative of the top, which we got is here, 2x to the -3/4. Oops, can't see my work. And we're going to minus the top, which is 8x to the 1/4 times the 2x. Okay, all over the bottom squared. And these ones, when we did with the, I think there was even one on your first exam, when we did the limit method with derivatives, these were really long. So this shortcut seems long. It really isn't. It really allows us to be able to do a fraction. So I can simplify this down. Takes a while, but you can simplify that down. Okay, because when you multiply, you add the exponents. I think the simplified version is -14x to the 5/4 plus 8x to the -3/4 all over x squared plus 4 squared. I think that's the derivative at the end there, if you simplify it, because this times this times this, and so forth. Add your exponents. Okay. You could also have, maybe I'll just show this last one here. You could also have one that mixes both. I think I'm just going to show you this problem, and there's more videos if you need more problems, but I have a top that is a product rule. So you could have to do a product rule inside of your quotient rule. So if I look, that's my top, that's my bottom. If I did the derivative of the top, then I have to do the product rule and simplify. Okay, and then I have the derivative of the bottom. So for the derivative of the top, it was like original times the derivative of this one, plus this one times the derivative of this one, and then simplify. This one was an easy derivative. Then you go to, all right, it's low d high, which is here, d high, minus high d low over this squared. You would never have to simplify, well, not never. You really could simplify that. I didn't even do it. I should never say you never have to simplify. I just feel excited if you can remember the rules and get it to here. That's like golden for me. Okay, so you could end up in the middle of a quotient doing a product, or vice versa. All right. Couple reminders. What was that I had on this one? Tangent line. I think we've if you end up having to do an equation of a tangent line, then make sure you use your original for the point and your derivative for the slope. Okay. What was the other thing? Where is the tangent line horizontal? It's been in a couple things, but I just want to remind you, it's where the derivative equals 0. So you find the derivative set equal to 0. I think you have one question like that. All right. Here's my video to help you. Have a good week.